covering it with different size cups to see what happens with the water, okay? So it's an experiment looking at pressure. So we're going to be looking at the pressure inside the cup versus outside the cup and what will happen, okay? So what we're going to start off by doing is we're going to, can we mute everybody right now actually? And if you guys have questions, just put your hands up, okay? So we're just going to, yeah? Yeah, go ahead, Derek. What's your question? Derek? What's up, Derek? What's your question? Oh, you want to?
I'm just gonna mute him.
Sorry, do you want to say it again, Derek? You don't have a. Do you have a question?
Oh yeah, we're gonna mute everyone.
Yeah, we're gonna mute everybody, and then if you guys have a question, just put your hands up, okay? And then we'll answer it for you. You will be playing with fire today, so please be careful. Get a staff or a parent at home to help you if you are nervous. Lighting matches and lighting candles. Sean has burned himself already, as you can see. Just kidding, no he hasn't.
Hold on for a second. You're muted.
There might be an explosion or two. I'm just kidding, there won't be.
No promises.
Sean, Derek. Sean's not very good at this experiment. We've tried 5 times and failed every. Just kidding. I'm just kidding, guys. It's gonna be really cool. It's gonna blow your socks off. So I hope you're wearing socks.
And guys, don't forget, it's science.
Oh, Derek has a question.
So there's no pressure.
What was that, Derek? You don't see what?
We don't see nothing.
Oh, they can't see us.
No, they are. We can see you.
No. They see the cup, but they don't see us. Oh, you don't see us?
But I see you.
Yeah, you see us?
Yeah.
We just see the people, that's all.
Oh, but you don't see the plate?
Yeah, now we do.
Now they do.
It might just be that the Wi-Fi.
Oh, he can see now.
Bye.
It's good now.
Okay.
Yeah, good now.
Okay. So, before we start, we're going to leave you with a couple things to think about while we're performing the experiment, okay? So keep these things in mind while we're performing the experiment. So, when we're looking at the flame, we're going to take a look to see if the flame will burn longer or shorter with different cups. So we're going to see if it takes longer for the flame to go out in different size cups, okay? So think about that while we're doing the experiment with the different cups. We're also going to look at whether the water level changes with the different cups as well, the different sized ones. So we're going to see if there's more water that fills up the cup or less water that fills up the cup. So we're going to pay attention to that too, okay? And then we're going to look at whether or not there are bubbles. So make sure you pay attention to whether you see bubbles or not, okay? So another thing to keep in mind before we start, we will be starting soon, don't worry. I'm just giving you lots of food for thought while you're performing this, okay? Sean said you're going to get hungry. Food for thought, get it? Dad jokes. Okay, so some important concepts to think about. So, when the flame is lit, when it burns, it consumes oxygen, okay? So the reason that the fire keeps burning is because it's eating up oxygen in the air, okay? So keep that in mind while the flame is lit inside the cup, okay? Nice. Another thing is thermal expansion. So I know that might sound a little bit complicated, but it's really not as complicated as it sounds, okay? So thermal expansion just means that when a gas is heated, it expands. Yeah, Derek has a question.
Yeah.
Do we need a lighter for this?
Well, you should have matches in your bag. Do you have matches in there?
Oh, okay.
Yeah, matches. Yeah, of course. Matches work, or a lighter. If you have a lighter, you can use that as well. So What thermal expansion means, it's not as complicated as it sounds. It just means that when you heat a gas, it expands, and when you cool a gas, it shrinks. So when it's heated, it expands. When it's cooled, it gets smaller, okay? Another thing is, I don't know if you guys have ever heard of a vacuum. Not what you use to vacuum the floors, but it's like a science concept. It means, a science term, yes, sorry. It means a low pressure area. So it just means an area that has less pressure than what is normally in the air. That might sound a little bit confusing as well, but it'll be easier to understand when we actually perform the experiment. I know pressure is like kind of something that's a little bit hard to understand because we don't see it, but hopefully this experiment will kind of get you to understand and see how air pressure works. I don't know if I worded that right, but anyways. So another thing to remember is that pressure is an invisible force, like I just said. So you can't see pressure, but it's there. So when you push on the table, that force, that's pressure, except pressure can be applied with air, you just don't see it, okay? And you're gonna see that here. So now what we're gonna do is we're gonna perform the experiment. I have my assistant Sean here, and he will be doing all of the work. Will I just sit back and relax? Just kidding, I'll be telling them what to do. So we're gonna be using food coloring for our water so that you guys can see what's happening. But at home you don't have food coloring because it's right in front of you, so you'll see it a lot easier. So what you're gonna start out by doing is taking some of the water, Sean, the water, and you're gonna fill up a plate, okay? So not so that it's overflowing, but you're gonna fill it up just enough so that it sits in there, exactly. So I'm gonna throw some food coloring in there, all right? Let's mix that up so everybody sees. Okay, that looks good. I think they can see that nicely. So now what we're gonna do is, which cup should we start with, Sean? Our big cup or our little cup?
With the little cup.
Little cup, okay. So what we're gonna do is Sean is gonna light the candle on fire. Uh-oh. Careful when you're doing this at home.
Oh, just kidding.
Sean.
Careful.
So once you light the candle, Sean's having a little bit of trouble. This is his first rodeo. Big flame. And now what you're gonna do is you're gonna take the cup and you're gonna put it over the flame, okay? And we're gonna cover the flame. Okay, so as you can see, the candle is still lit in the cup because the flame is eating oxygen in the cup, okay? So now, you see how the flame went out? So what happened here is that when the candle was lit, it made all of the air in the cup really, really hot, okay? And do you remember what I said? When air is hot, it expands. So then when the candle went out, the air cooled. And what happens is that when the air cools, it gets smaller. So the gas particles, they shrink. So air goes from expanded to shrunk. So then what happened there is all of the air outside of the cup, it needed to equalize the pressure in the cup. So it created a vacuum. So what that means is that in order for the air in the cup to be equal to the air outside the cup sucked up a bunch of water so that now the air outside the cup and the air inside the cup is equal, okay? So we'll try that. What?
I was just going to say, you could also look at it as when you have fire needs one main thing to keep thriving, which is oxygen, right? So when we lit the candle inside there and it ate up all the oxygen, it was looking for more oxygen, therefore it sucked up the water, trying to suck oxygen from on the outside of the cup back in. So that's why the water has lifted up the candle a little bit. Does
Well,
that make sense?
actually, that's a misconception.
Is it? Okay, go ahead.
So, as Sean explained, that's actually a misconception with this experiment. So, what people think is that because the candle is eating up the oxygen, that it's replacing the oxygen with water. But if that were to happen, the water would have moved up very, 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 very slowly in the cup, okay? But did you see how the water just shot up really fast? Like we almost couldn't even see it. It just like shot up really quickly. So that's, how do I explain this? Okay, so, so when the flame is in the cup and it's eating up the oxygen, it's also replacing that eaten up oxygen with carbon dioxide, okay? So the pressure or the volume of gas in the cup stays the same. So it isn't actually eating up the oxygen, it's replacing it with carbon dioxide, okay? So the volume of the gas is the same in the cup. Might be a little bit hard to understand, but basically a misconception with this experiment is that it's eating up the oxygen. But scientists were able to prove through doing this experiment and a lot of different math that it's actually related to a pressure imbalance in the air and in the cup, and not because the cup is eating the oxygen, okay?
I was wrong.
But it's trial and error. That's what science is about. It's all trial and error. But that's a very common misconception. It was only recently that they disproved that. So only recently we actually found out that it's related to pressure and not to eating oxygen.
Like this morning? Like
Yeah, this morning, 5 minutes ago is when they found that out, right before we started the experiment. Just kidding. So now let's take the cup off. Nice, that was cool. Okay, so now we'll try it one more time with the small cup so you guys can see it again. We'll do the small cup again, just so you guys can see it again after having it explained to you.
Well, that one lit easier.
No kidding. Okay, so he's gonna put the cup over top, and once that flame goes out, it's gonna suck the water up really fast, okay? Just watch. There we go.
Ooh.
But if that misconception were true, it would have taken a lot longer for that water to rise. A lot longer, okay? So now what we're gonna do is we're gonna try it with a big cup, okay? And we're gonna see if there are changes in anything. We're gonna see if it takes longer or if it's a longer time or a shorter time for the flame to go out. Do you guys have any ideas of what you think? Do you think with the big cup it's gonna take longer time for the candle to go out or the flame to go out, or do you think it's gonna take less time? Anybody have any ideas?
Jenna.
Oh, Jenna has an answer. Jenna, do you think it's gonna take longer, less time, or more time for the flame to be put out?
Yes.
Yes? More time? Okay, good guess. Anybody else have any guesses? Allie, what's your guess? Sorry, what was that? Do you want to say it again? Longer time? Okay, perfect. Anybody else?
Derek.
Okay, Derek, what's your guess?
This one took about 5 seconds.
Yeah, so do you think with the bigger cup it's going to take longer or shorter time?
I say shorter.
Shorter? Okay, so we have some guesses of longer and some guesses of shorter. So now we're going to put it to the test, okay? Go ahead, Sean. Yeah, so, oh, it did take longer. Okay, so Allison already tried it and it took longer. So we're going to show you guys. Okay, ready? So let's watch. Oh, so it does look like it's taking longer for the flame to go out. What? But there is a lot more air in this cup, so there's a lot more oxygen that has to be replaced with carbon dioxide in this cup, okay? So basically it's taking a lot longer for the flame to replace the oxygen with carbon dioxide. So it took a lot longer. But what do you see? Is there more water in this cup than the last cup, or is there less water? Do you guys...
Should I unlock or unmute?
So there's actually more water, but it's because there's more air in the cup, so it has to suck up more water. So there's much more water in this cup than there was in that cup. So maybe we'll try this one more time so you guys can see it again. That's my favorite part. What was that, Allison?
Can I try it again or no?
Yeah, go ahead, try it again. I think it's pretty cool to see.
Just be careful using the matches.
Yeah, be very careful. Ooh, smells like fire in here.
I can do that thing.
Don't set off your smoke alarms. Just kidding. There isn't enough.
Derek has question.
Oh, Derek has a question. What's your question, Derek?
Well, it was going longer, but it's out now.
Yeah, so exactly. It takes longer because there's more air in the cup. So it takes a lot longer for the flame to go out. But then it also sucks up more water.
It's pretty fast when it sucks up the water already.
I guess these two should hold a picture right in.
There we go. See, it just kind of shoots up. As soon as the flame goes out, it just shoots up. Pretty cool though, hey?
Yeah.
Okay, so that's our experiment. So I hope you guys kind of understand now a little bit about how pressure works.
Yeah.
Yep, Derek gets it now. Here, I'll try and explain it a little bit on the board as well, okay? Do you guys have any questions about this? Maybe we can explain it a little bit more if there's something you didn't understand.
I got one.
Yeah, what's your question, Derek?
Will it last long in the lake?
With a
When you put it there?
What was that?
He wants to know if you can do this in his lake at the cabin.
Ooh, I don't know about that. I don't know. There's too much water to do it. But you can do it like in your cabin with water.
Oh, you got us,
Yeah,
Derek.
you got us, Derek. So I'll try and explain it on the board. We'll take a look at it one more time, okay? So you have your candle. This is just to summarize just everything that we've talked about and we've saw, okay? So you have your candle. You have your candle and it's eating the oxygen, but it's also, that's the oxygen. It's getting rid of the oxygen, making carbon dioxide. So the volume in the cup of the gas stays the exact same in there, okay? But what happens is when this flame goes out, the particles of gas, they go from very big to very tiny, okay? So they go from big to small. So the pressure equals less. Less pressure in the cup. More pressure outside. Pressure goes from high to low. So all of this water shoots right inside the cup, okay? And that's our experiment. Kind of cool, hey? Yeah, I think it's kind of fun. Gives you a nice visual of how pressure works. So no more questions? Questions, comments, what do you guys think? Did you like that?
I'm just unmuting them.
Yeah? Okay, we're just gonna mute you. Did you guys like that? Did you enjoy the experiment? Yes, no, maybe so? Okay.
It's kind of freezing.
Okay, so what I think we'll do, go ahead, pull it up. Next.
Bill Nye,
Is we'll pass you back over. Now you guys are scientists. Kind of cool. So what we'll do is we're going to pass you back over to Gentile and you can, we'll say our goodbyes and we'll see you guys at 1 o'clock, okay?
Would you like to read that?
Bye guys, see you at 1.
Derek has question, I think.